In this video, we're going to talk about solving systems of linear differential equations by systematic elimination, section 4.9 of the textbook. And there's other methods discussed later in the textbook to handle these types of problems later. That's not a core objective of this class, to know how to do that with eigenvalues and eigenvectors and matrices. That will require some linear algebra to know how to do that. So this is the preferred method for this 200 level course as opposed to the method that's taught later, which is taught in a 400 level course. So I'm going to work through the odd number problems of the textbook, and you have some free choices here on how to move forward with your solutions that may not make your solutions match mine exactly, but I'm going to go with the choices that would be used by the textbook here to get an answer similar, if not always identical to their answer. So here's your first problem here, and we want to get our x's and y's on one side and our constants on the other is typically how we want to transform these. And we want to write our differential operators with the notation that dx dt will be a capital D x, and d2x dt2 we'll write as d squared x, and so on. We'll use that notation that we used with the annihilator approach when we did that. So this equation here is going to start off as dx minus 2x plus y equals 0. This equation will start off as x minus dy equals 0. And then right here, I want to factor the x out. And I have the operator d minus 2 on x plus 1y equals 0. And then I have 1x minus dy equals 0. And you see how I have my x's and my y's lined up. And I want to use differential operators to solve for one of the, to eliminate one of the parameters here, one of the variables. So I'm going to use the differential operator on the first equation. So I get a dy minus a dy will be 0. So that's going to turn this first equation into d times d minus 2 x plus dy equals 0. The derivative of 0 is still 0. Leave the second equation alone, x minus dy equals 0, and we'll eliminate this. Now we're going to have d squared minus 2d plus another 1 x is equal to 0. So that's a d minus 1 squared. X equals 0. We'll change that into the auxiliary equation. M minus 1 squared equals 0. M equals 1 multiplicity 2, giving us a solution for x, as x equals c1 e to the x, e to the t. T is our variable here, plus c2 t e to the t. Now we're going to have to go back here to this equation and solve for y, that y is equal to 2x minus dx dt. So let's find dx dt. And that is c1 e to the t plus C2 e to the t plus C2t e to the t. When we use the product rule here, take the derivative of the first part, leave the second part alone, plus derivative of the second part, leaving the first part alone. So this becomes dx dt is a C1 plus C2 e to the t plus C2t e to the t. Substituting that into our equation here for y equals 2 times x, which is C1 e to the t plus C2t e to the t minus C1 plus C2 e to the t minus C2 t e to the t. We have y equals 2 C1 minus C1 minus C2 e to the t plus 2 C2 t e to the t minus C2 t e to the t. So y equals C1 minus C2 e to the t plus C2 t e to the t. So there's my x equals portion of my answer right there. And there's my y equals portion of my answer right there. That was number 1 from the textbook. Now let's go ahead and look at number 3 from the textbook. Dx dt is equal to a negative y plus t. Dy dt is equal to x minus t. I see the possibility here of this being non-homogeneous and us needing to find a complementary solution and a particular solution for x and y here. Let's see if that's what happens. So we have dx plus y equals t. And I have, when I bring this over and this over to keep the x positive, x minus dy is equal to t as well. So I'm going to differentiate the first equation here. Get d2x plus dy equals derivative of t with respect to t is 1. Let's leave this one alone and eliminate the dy. So we get d squared plus 1x is equal to t plus 1. Solving for my complementary solution, m squared plus 1 equals 0, m squared equals negative 1, m equals plus or minus I, meaning that xc is equal to c1 cosine t plus c2 sine t. My xp is going to be at plus b. I'm going to need to find the second derivative of that. So xp prime a, xp double prime is 0. And I want second derivative plus the original. So 0 plus at plus b is equal to t plus 1. Tells me that a is equal to 1 and b is also equal to 1. making my xp equal to t plus 1. That gives me x equals c1 cosine t plus c2 sine t plus t plus 1. Now my y needs to be equal to t minus dx, or dx dt. Dx is equal to a negative c1 sine t plus c2 cosine t plus 1. So y equals t minus all this, so that's plus c1 sine t minus c2 cosine t minus 1. So y equals c1 sine t minus c2 cosine t plus t minus 1. And there that is. Move on to number 5 from the textbook now. Number 5 starts off with d2 plus 5x minus 2y is equal to 0, and a negative 2x plus d squared plus 2y is equal to 0. And we need to get something that will zero out. I'm going to try to zero out the x part by multiplying the top equation here by 2. 2d squared plus 10x minus 4y equals 0. And then taking the differential operator d squared plus 5 across the second equation. So negative 2d squared minus 10x, and then plus d squared plus 2 times d squared plus 5y is equal to 0. These will zero each other out. I have d to the 4th plus 5 plus 2 is plus 7d squared, then plus 10, and then minus this 4. Y equals 0 is d to the 4th plus 7d squared plus 6y equals 0, making this d squared plus 1 and d squared plus 6y equals 0. So let's turn those into auxiliary equations. M squared plus 1 equals 0. M squared plus 6 equals 0. M squared equals negative 1. M equals plus or minus I. M squared equals negative 6. M equals plus or minus root 6I. So my y equals c1 cosine t plus c2 sine of t plus c3 cosine root 6t plus c4 sine root 6t. And we're going to solve for x using equation number 2. 2x is equal to d 2 plus 2y, which is d2y plus 2y. So let's figure out what that is. dy is negative c1 sine t plus c2 cosine t minus root 6 c3 sine root 6t plus root 6 c4 cosine root 6t, and d2y is negative c1 cosine t minus c2 sine t minus 6 c3 cosine root 6t minus 6 c4 sine root 6t. Two x is equal to this. Negative c1 cosine t minus c2 sine t minus 6 c3 cosine root 6t minus 6 c4 sine root 6t plus 2 times the original, 2c1 cosine t plus 2c2 sine t plus 2c3 cosine root 6t plus 2c4 sine root 6t. So that's going to be 2x is equal to c1 cosine of t plus c2 sine of t minus 4c3 cosine root 6t minus 4c4 sine root 6t, making x equal to 1/2 c1 cosine of t plus 1/2 c2 sine of t minus 2 c3 cosine root 6t minus 2 c4 sine root 6t. And here's my y equals equation up here. And here's my x equals equation, oops, down here. All right. All right. Let's move on now to number 7. Number 7 starts off as d2x dt2 equal to 4y plus e to the t, and d2y dt2 is equal to 4x minus e to the t. So we're going to change the notation here to make it easier for us to make this d2x minus 4y is equal to e to the t, and 4x minus d2y is also equal to e to the t. So now we want to probably eliminate the y's here. It really doesn't matter, but that's the way that I'm going to go for this. So I'm going to take a second derivative of the first equation here. I'm going to multiply the second equation here by a -4. So make this d4x minus 4d squared y. Second derivative of e to the t is still e to the t. And then I'm going to multiply by a -4 here. So this is -16x plus 4 d2y is equal to a -4 e to the t. And when I add and eliminate my y's, I get d4 minus 16x is equal to a -3 e to the t. Let's go ahead and make this d squared minus 4 times d squared plus 4x is a -3 e to the t, which makes this d plus 2 times d minus 2 d squared plus 4x is a -3 e to the t. Changing that to auxiliary equations, let's see, we have to find our homogeneous portion of our solution, our complementary portion of our solution, m squared plus 4 equal to 0, m plus 2 equals 0, m minus 2 equals 0, m squared plus 4 equals 0, m equals a -2, m equals a +2, m squared equals -4, which means m equals plus or minus 2i. I'm going to write the positive exponent part first. So xc is equal to c1 e to the 2t plus c2 e to the -2t plus c3 cosine of 2t. Give myself a little bit more space here. C4 sine of 2t. There we go. All right, so now my xp is going to have to be something in the form of a e to the t, and I need to get to the fourth derivative of that. So d is this, d2 is still this, d3 is still this, and d4 is still that. So we have d4 minus 16 times the original is equal to a -3 e to the t. So a -15a e to the t is equal to a -3 e to the t. And -15a is equal to a -3. A is equal to 1/5, meaning my xp is equal to a 1/5 e to the t. That makes my x equal to C1 e to the 2t plus C2 e to the negative 2t plus C3 cosine of 2t plus C4 sine of 2t plus 1/5 e to the t. So that's just my x equals portion that we found. We still need to find the y equals portion. To do that, we're going to use our first equation there. We can say for y is equal to d2x minus e to the t. So let's find d2x. Let's just come down here. X equals c1 e to the 2t plus c2 e to the negative 2t plus c3 cosine 2t plus c4 sine 2t plus 1/5 e to the t. Let's just do that. There we go. And let's put this in a box. Here is the first part of our answer. I need to get up to d4x. So dx is 2c1 e to the 2t minus 2c2 e to the negative 2t minus 2c3 sine of 2t plus 2c4 cosine of 2t plus 1/5 e to the t. d2x is 4c1 e to the 2t plus 4c2 e to the negative 2t minus 4c3 cosine of 2t minus 4c4 sine of 2t plus 1/5 e to the t. d3x is 8c1 e to the 2t minus 8c2 e to the negative 2t plus 8c3 sine of 2t minus 8c4 cosine of 2t plus 1/5 e to the t. d2 is minus c3 minus c4, and then I guess that's okay, because I can just leave that as that, but let's see. Yeah, I just need to go to the second derivative here. So second derivative, because we're using this equation here, so 4y is equal to 4c1 e to the 2t plus 4c2 e to the negative 2t minus 4c3 cosine of 2t minus 4c4 sine of 2t plus 1/5, and then minus 1 is going to be minus 4/5 e to the t. And then we're going to divide by 4. And this is going to be y equals c1 e to the 2t plus c2 e to the negative 2t minus c3 cosine of 2t minus c4 sine of 2t minus 1/5 e to the t. And there's your y equals portion that goes with your x equals portion from earlier. So far, we've stayed with two equations with two unknowns. And we'll keep doing that for a little bit, but we are going to get some examples coming up here that are going to be three equations with three unknowns. So let's look now at number 9. Number 9 says dx plus d2y equals e to the 3t, and d plus 1x plus d minus 1y is equal to 4e to the 3t. Notice that there's no variable x or y all by itself, just sitting here in this one. So that's going to maybe make things a little harder for us towards the end of the problem. But let's go ahead and let's eliminate x here by using the differential operator d plus 1 in the numerator. And d plus 1 is the derivative plus another original. So that's the derivative of this plus the original is going to be 4e to the 3t. And we want just the regular derivative operator d on the second equation, but we want to also multiply by a -1. So I get a negative d plus 1x minus d times d minus 1y is equal to a negative, and then we're going to use the differential operator here. 3 times 4 is 12, e to the 3t is a negative 12, e to the 3t. Okay, let's go ahead and add those together. These will eliminate, and we get d3 plus d squared minus d squared plus dy is equal to a negative 8 e to the 3t. And middle terms zero each other out, and I see a common factor of d is d times d squared plus 1 y is equal to a negative 8 e to the 3t. So auxiliary equation, m times m squared plus 1 equals 0, m equals 0, or m squared plus 1 equals 0, m equals 0, or m squared is -1, m equals plus or minus I, making my complementary solution for y equal to c1 plus c2 cosine of t plus c3 sine of t. My particular solution for y is going to have to be in the form of a e to the 3t. And let's see, we need to get to a third derivative, it looks like. a third derivative plus a first derivative here. So dyp is 3a e to the 3t. d2yp is 9a e to the 3t. And d3yp is 27a e to the 3t. So third derivative plus a first derivative is equal to negative 8e to the 3t. So 27 plus 3 is 30, a e to the 3t. So ignoring the e to the 3t's, 30a is a negative 8, a is a negative 8 over 30, or a negative 4 over 15. That makes my yp equal to negative 4 over 15 e to the 3t. And my y total is c1 plus c2 cosine of t plus c3 plus c3 sine of t minus 4 over 15 . It's 4 over 15 e to the 3t. Now that only gives me my y portion of my answer. I still need to find my x portion of my answer. And so to do that, I'm going to have to use equation 1 is easier to work with here, but I'm going to have to come here and say dx plus d2y is equal to e to the 3t. So I need to find d2y. dy is equal to a negative c2 sine of t plus a c3 cosine of t, and then minus 4/5 e to the 3t, and d2y be negative c2 cosine of t minus c3 sine of t minus 12/5 e to the 3t. So dx plus all this, so that's minus c2 cosine t minus c3 sine of t minus 12/5 e to the 3t is equal to e to the 3t. So let's go ahead and move everything to the right-hand side. That is not dx, so dx is equal to c2 cosine of t plus c3 sine of t. Then we're going to have 12/5 plus 5/5. It's going to be 17/5 e to the 3t. So let's go ahead now and look at equation number 2, which now that we have dx, says dx plus x, it really says d plus 1 x plus d minus 1 y is equal to 4e to the 3t. So that means that this is dx plus x plus dy minus y is 4e to the 3t. So we just found dx, which is c2 cosine of t plus c3 sine of t plus 17/5 e to the 3t plus our original x plus dy, which is up here, negative c2 sine of t plus c3 cosine of t minus 4/5 e to the 3t minus our original y up here, c1 c2 cosine t, c3 sine of t, minus a negative is a positive, 4 over 15e to the 3t. That all needs to be equal to 4e to the 3t. So when we simplify here, then we have a, let's see if anything goes away, negative c2 cosine of t, a negative c3 sine of t, and we have c2 sine of t. That doesn't cancel or reduce with anything. So everything else is x minus c2 sine of t plus c3 cosine of t minus 4 over 5. Well, let's multiply and make that 15ths. So that's minus 12. And then that's plus 4 is minus 8 over 15 e to the 3t. So that's this, 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 this. This is accounted for. I still have a minus c1 here, and that is 4e to the 3t on the right-hand side. So x is equal to c1 plus c2 sine of t minus c3 cosine of t, and then multiply by 15 over 15 here is 60 over 15, plus 8 is 68 over 15 e to the 3t, and then we have c1 minus c3 plus c2. I've missed a negative 17 over 15. Where did I miss that? dx, there it is right there. So this comes over as minus 17 over 15 e to the 3t. There it is. Minus 17 over 15 e to the 3t. So x equals c1 plus c2 sine of t minus c3 cosine of t. Minus 17 here is plus 51 over 15 e to the 3t. Both of those are divisible by 3. So x is equal to c1 plus c2 sine of t minus c3 cosine of t plus 17 over 5 e to the 3t. There we go. And there's my x, and my y is up here. I'm going to do one more before I stop to make a part 2 video for this. So I'm going to wrap up this video with number 11 here. So number 11 says d2 minus 1 x minus y equals 0, and d minus 1 x plus dy equals 0. So I'm going to just find dy here. Is very simple. D times d squared minus 1x minus dy equals 0. D minus 1x plus dy equals 0. It's going to be d cubed minus d plus d minus 1 x equals 0. D cubed minus 1 x equals 0 is the same thing as d minus 1 d squared plus d plus 1. Changes into m minus 1 m squared plus m minus 1, sorry, plus 1 equals 0. We have m minus 1 equals 0, m equals 1, m squared plus m plus 1 equals 0, m squared plus m equals negative 1. Half of the middle number squared is a quarter on both sides. M plus a half squared is negative 3/4. M plus 1/2 equals plus or minus root 3 over 2i. M equals negative 1/2 plus or minus root 3 over 2i. Alpha equals negative 1/2. Beta equals root 3 over 2 for my complex number alpha plus or minus beta I. So that means that my x equation is c1 e to the t plus, and then alpha is negative 1/2, so that's negative t over 2, cosine of root 3 over 2t plus e to the negative t over 2 sine root 3 over 2t. Probably just going to rewrite that here in a second once I come all the way down. X equals c1 e to the t plus e to the negative t over 2 times c1 cosine root 3 over 2t plus c2 sine. Sorry, this is 2 because c1 is already out there, and this is 3 sine root 3 over 2t, like that. There we go. You can distribute the e to the negative t over 2 inside the parentheses if you would like to. Let's see. That is my x equals equation right there. And to find y, I'm going to use the y equals to d2 minus 1 x, which is d2x minus x. Let's find d2x. Dx is equal to c1 e to the t, and then take the derivative of the first part, leaving the second part alone. Plus, leave the first part alone, take the derivative of the second part. Like that. So dx is c1 e to the t plus e to the negative t over 2 times, so this is negative 1/2 c2 plus root 3 over 2 c3 cosine of root 3 over 2 t plus, and then negative 1/2 c3 minus root 3 over 2 c2 sine of root 3 over 2t, like so. Then d2x is c1 e to the t minus 1/2 e to the negative t over 2 times all this. plus this times the derivative of the inside is going to be a negative root 3 over 2 times all this. So that's root 3 over 4 minus 3/4. This is C2, C3 sine root 3 over 2. And then positive root 3 over 2 times that minus root 3 over 4 C3 minus 3/4 C2 cosine root 3 over 2t. And then we're going to combine those parts there. C1 e to the t plus e to the negative t over 2 times, and then negative 1/2 times the negative 1/2 is 1/4 C2. It's minus root 3 over 4 C3. Then we have that's cosine, so that's here, minus root 3 over 4 C3 minus 3/4 C2 cosine of root 3 over 2t. Then we have plus, then we have negative is a positive 1/4 C3 plus root 3 over 4 C2 plus root 3 over 4 C2 minus 3/4 C3 sine of root 3 over 2t. So d2x is C1 e to the t plus e to the negative t over 2 times, all right, let's combine some like terms here. 1/4 minus 3/4 is negative 2/4, which is negative 1/2. And then this is going to be negative root 3 over 2 C3 cosine root 3 over 2t. And then this is 1/4 minus 3/4 is negative 2/4, which is negative 1/2 C3. Let's actually make that second since C3 comes after C2. So minus 1/2 C3, root 3 over 4, root 3 over 4 makes a root 3 over 2 C2. And that is my sine of root 3 over 2t. Close that up. Now that's got me my d2x that I need for my equation here. So I need d2x minus my original x. And my original x is right up here still. So that's minus C1 e to the t. And then minus so plus e to the negative t over 2 times, and I'll change the signs on the inside here, for what I need. So negative C2 cosine. And then negative C3 sine. All right, so that makes my left-hand side the same as y. And that is e to the negative t over 2 times 1/2 minus 1 is negative 3/2 c2 minus root 3 over 2 c3 cosine root 3 over 2t plus, and then root 3 over 2 c2. Negative 1/2 minus 1 is negative 3/2 c3 sine of root 3 over 2t. And sine 3 over 2 c2 minus 3. And that's it for y. And I think you see why I wanted to call it right there after that problem to give both you and me a break. So we'll come back now and look at 13 through 19 odd in the next video. So see you for the next video.